I have Logan Farrell on the call today. And he is the co-founder and CTO of Rugged Robotics, out of Texas, from what I see, right?
In Texas.
And basically, to give you a little background on Logan, because I find as entrepreneurs and leaders, a lot of times we don't include everything we've done. So I'm going to do that for Logan, and then we're going to get into what he's doing at Rugged. But basically, he is, like I said, CTO and co-founder of Rugged Robotics. He has worked at NASA previously. During that time, he led a team of 8 to develop technologies necessary for robotic manipulation onboard spacecraft. He has also led teams to make software packages to enable generic encoding and manipulation tags. I don't know why I can't say that word today. I don't know.
It's a tough word.
Yeah, apparently I should have practiced it like Ron Burgundy and Anchorman before he started saying stuff. Unique, you see, I couldn't do that either. I'm apparently no Ron. So anyhow, though, the focus of software, focus on software to work in the same spaces as humans. Let's see, design and developed constructed propulsion actuator for the lunar rover. So basically a long list of accomplishments. And I'm always inspired when I talk to people that have been working with NASA, because I'm just always fascinated, amazed by that. So I appreciate the fact that you're taking the time to be on our show. And I want to find out more about what you're doing and what inspired you to start Rugged Robotics. So now it's your turn, Logan. Go ahead and fill in the blanks that I left.
Oh, gosh. Well, you got the backgrounds. Great. So appreciate that. NASA got the chops, and then really kind of starting from the beginning with Rugged. Derek, my co-founder, and he's the CEO. His background is construction and business. So he kind of found the initial need, and he called me up. He's like, hey, you want to solve problems that real people have on planet Earth, like right now? Yeah, that sounds great. Like, NASA was fun. I worked on super cool stuff with super cool and passionate people. And the stuff they do is important. It's 15-year out technologies. It's advanced R&D, which was fun to do, but wasn't as impactful for me personally. So I was really intrigued by this concept of, let's go solve a problem today that people have right now. So that's what we've done. We've built a company that delivers automated layout for commercial construction. To kind of give the listeners a bit of context, layout is the process of taking the digital model and where do you actually build it in the real world. The example I always use is, picture a high-rise building downtown somewhere. You can kind of see the steel going up and the concrete. And at some point you have an empty concrete floor. You have a digital model where all the drywall is supposed to go, all the HVAC ducts, the outlet, the dimmer switches, the hot and cold water lines, the sinks, the toilets, all of that's modeled. They know where it's supposed to go. But you got an empty concrete floor, and how do you translate that into the real world where it's supposed to be built? And a lot of trades are still doing paper drawings, tape measures, chalk lines, and Sharpies. There are some using more sophisticated equipment like total stations, which are like indoor survey equipment. Some are using, at least PDFs on tablets is more common now, but even that, you'll still see the big drafting tables. So it's a human process. It's a slow process. And it's the long pull on a lot of projects. So we identified this is a problem. If you build a wall in the wrong spot, a lot of times you don't catch that until the building's almost done. And I tell you, it takes a lot of money and time to tear down an entire room and rebuild it once you've built most of a building. So if you can catch those early and do that, so that's what we do as a company. We've built a robot that, instead of crawling around on your hands and knees with the chalk line, the robot just drives around, locates itself in the building, takes that digital model and recreates it on the floor. Does it quite a bit faster than people. It's a lot better at math in its head than people are. And it doesn't need coffee breaks. It just kind of keeps going. So it's really trying to augment the guys in the field. They have such a hard time getting labor in construction right now. There's not a push to trades in the United States. So there just aren't people who do this as a profession as much anymore. So it's not replacing somebody because it's cheaper. It's hard to find people. So this is something that enables people to do more, so the people that they have can be more productive.
Logan, so I don't know if you know this about me or not, but I was a union electrician before I got so into automation. Yeah. And so I know exactly what you're talking about. And believe it or not, if you look me up after the show, I'm building what's called a green magic home, which is looks like a hobbit house. It's covered in plant material. My landscaping company, Langton Group, builds them. But here's the thing I want to add to the things that Logan just said. I have people working on that house right now as I'm sitting here doing this podcast, but they're there because I already laid it out. So the other thing that you talk about with layout, and as I'm listening to what you said, Logan, is I can't tell you when I was an electrician how often you'd have the laborers that didn't have something to do because the layout guy wasn't there to lay out ahead of them. Mm-hmm. And I can tell you as an electrician, I can't tell you how often we were delayed in construction because a carpenter was short people to lay out the walls, because once they're laid out, those guys slap that stuff up like wham bam, especially steel studs in commercial buildings. Oh yeah. But I've seen layout takes more time than anything. And it's a lot of times when you're doing it across these big spans, you got lasers, you got a couple of people. And like you said, you're pulling lines, you're measuring, and one guy comes up, one guy thinks it wants to get down to an eighth or a 16th, and another guy thinks within a quarter is close enough, right? So, so I feel, yeah. So I feel like what you did is another example of technology solving real world problems, So we see what the inspiration is. So now, let's talk about like kind of how you're getting to market. Do you sell your systems? Do you put them out in subscription models? Like how do you work on getting this great tool in people's hands?
Yeah. So our business model is unique amongst our competition. We do layout as a service. So we are at this stage a layout company for a contractor. And when they ask, how are you going to deliver this faster and cheaper than I am? I will then tell you I'm going to use a robot for it. So the way the business works in construction, it is you hire the person that's most qualified to do that job. The builder hires the general contractor to manage the building. The general contractor hires the drywaller, the mechanical sub, the electrical sub, the plumbing sub, because they're really good at doing those things. And then they'll hire fireproofers who have all the right equipment to go do fireproofing well. And they'll hire, core drillers to go drill the holes for everybody all at the same time. And even the drywallers got a separate group of people they may contract to do tape and board. So we're fitting into that model. We're going to come in and do a job for you. You'll pay us and we'll leave. And you don't have to worry about, who's going to run the robot? Who do I have to train up to do this? Where am I going to keep it? And like the logistical challenge, if you're going to use these machines well to make a lease effective, you've got to use it a certain amount of time. So then how are you going to move your field engineer around? How much is your field engineer's time worth? So it's not just the cost of the lease, it's the field engineer, it's the training. Now that guy's got to move around and who's deciding what projects he's going to and managing those schedules. So we handle all of that for our customer because that's the problems the customer wants to get rid of are those problems. So you say, hey, I'm ready for layout on Monday. Great. We'll be there Monday.
Well, and they're saving a lot of money too on work comp and all the fully burdened stuff that goes with a person because with you guys, they're just paying you like a 1099 subcontractor, right? So Exactly. It's cut and dry for them. Give me a price. This is what it is. And they can put that in a budgetary number and they don't have to figure about going over or under. It's just the price.
Exactly.
Yep. So so your system basically goes ahead of the people. So you probably, how do you guys quote that out then? You quote per linear feet that you're laying out? Do you quote like how do you come up with the cost to the GC?
So the way we present the number is cost per square foot because that's the way people think about it. But to kind of pull back the curtain a touch, it's really a combination on our end of how big is the space and how dense is the information. Part of what we try and do is print multiple trades at the same time. If I'm driving a robot across the floor, why don't I put down the mechanical, electrical, and drywall all at the same time and save everybody a lot of headache and everybody's off the same model and it's just to solve that problem. So however many trades we're doing, we'll then factor in, and the way we think of it internally is number of prints. So linear feet translates to a certain number of prints that are required by the robot. number of hanger locations, number of electrical outlet locations. Those are all prints. So we take, think of a warehouse with one wall. Let's say two walls on opposite ends. There's a certain cost associated with me sending a person there, them setting the robot up, driving it around to print the one wall, drive 1,000 feet down the hall to print the second wall. Like that costs a certain amount of money just to do that. And then think of the opposite end of the corner of a hospital where they have a ton of imaging equipment and fluid lines. You might be doing 2,000 square feet, but it's so densely packed with information that it takes a long time. So we basically factor those two pieces in to come up with the overall cost. So a hospital is the most expensive because it is a large footprint with a ton of information, and a warehouse would be the least, or really actually an open concept office tends to be the least expensive because it's, smaller with fewer walls, fewer mechanical, electrical, etc.
So, so my mind is full of questions right now, and I'm straying a little bit. I'm straying a little bit off my pre-show research now that you're kind of filling my mind space here. So, first of all, you're selling it to, you're selling it to the GC or the carpentry contractor? Because when I look at it, when you're laying out all these other mechanicals, I know the way that when I was an electrician, how we would have submitted a bid, and that bid includes us doing the layout, reading the drawing, doing it. So how do you recapture, or how does that GC, and I guess you'll tell me in a second how you sell that out, but how do you guys recapture the labor that all of those trades should save with your system? Because I'm sure the GC is trying to get them to reduce their bid because it's all laid out, right?
Yeah, there are a couple of different avenues depending on the general contractor, the trades, and the timeline. So we prefer to sell to general contractors. We view ourselves like, if people are familiar with the industry, fireproofers do fireproofing for all trades because they're the best equipped to do fireproofing. And they sell a couple different ways too. We prefer to sell to the general contractor because we can do the trade faster and as or more accurate than the people for all trades. However, if those bids have already been gone out and we're engaging on a project, sometimes it's a combination of GC and the drywaller because they'll both benefit. So actually both pay the fee, part of the fee. We'll also sell directly to subcontractors and then sell across. So if we're on a job for the drywaller, that's the most common. They have kind of the biggest layout challenge. So we will go work for the drywaller and then reach out to the mechanical, electrical, plumbing subs and say, hey, we're going to be here anyway. Would you like us to print your stuff too? So we can really work for anybody on the project because everybody gains something a little different from us and our work. The GC gains the most because we're compressing schedule, limiting the amount of rework, and the GC pays the most for time because they have to carry all of the insurance like you were talking about and all the site logistics. And if they can be off a site 3 weeks earlier, they can turn that over to the developer who can then lease the space 3 weeks earlier, and they're not covering the trailers and the insurance. So they gain a lot of money with time, which is one of the big benefits for the GC, but the benefits still exist for the drywaller. They can still lay out faster. They can augment their staff. They can put more information on the floor. If they give us a model that has the layers of board, we can print the layers of board for them so that their guys putting up the board don't have to reference the drawing. They just look down and say, oh, this is a priority wall. This is 2-hour fire rating. I'm going to need 2 layers of board and this I'm going to do the other side.
Awesome. So, because I would assume, even if the GC already put out the bids, all you need is their contractor bid list, and then you just go and you solicit that list because they already have it. So it's easy for you. So you can only lay out on the floor though. So you're not putting anything up in the ceilings. You have no way to get like the ceiling work laid out, just the stuff that's in the wall on the floor.
Correct. So we lay out what they're putting on the floor, we put on the floor. So, and a Sharpie mark for the hanger location. We'll put that hanger location. We'll also put, if they give us the schedule, the hanger number, the prefab number, the bottom of pipe elevation, the pipe diameter. Like we'll print all of that with the mark because for us, printing all of that is the exact same as putting an X on the floor. So we'll print all of that. So almost the exact same layout they're doing now, just more information, faster, and more consistent.
Yep. So the other thing is that you didn't even bring up, but a lot of people, and sorry, I'm just bringing up all the pluses because that's what I love about automation, because people never think of the small things. But, a lot of contractors have liquidated damages if they go over. So if somebody says they're going to be done in July, but that construction project goes past, they have to come up with a credit back. So you said time, for them, they can finish early, but there's also damages if they finish late. And that's why there's bid bonds and stuff. So, I mean, you guys are really solving a huge problem. So is that like, what you said your CEO, the person that called you and said, hey, you want to solve earth problems? What was it that made him see this? I mean, was he having trouble getting stuff laid out fast enough? Like, explain that background a little bit.
Yeah. So like I said, Derek's background is construction and business. So he's got a bachelor's and master's in construction and fire protection engineering. He spent over 10 years in construction. He actually hung sprinkler pipe in high school and college. He was a professional engineer in the Boston area doing code consulting for fire safety. So he knew the industry well. He went and got his MBA from MIT. So he learned, the business aspect of things, spent time doing some corporate consulting, and then wanted to get back into construction. So construction's his passion. He learned a lot of the business acumen and wanted to get kind of into the longer view of construction was his goal originally. So he starts asking around and he realizes that, construction's trying to win a project today and deliver it. There's just not a lot of time in the construction world to think about tomorrow. So he wanted to start helping them think about tomorrow. So he starts asking around, what are the problems? And what came up was labor availability was one of the biggest problems. They just can't find the people to do the work, like I mentioned earlier. And so he's like, okay, how can we help the labor problem? And then he's like, well, he started looking around, and he has a good story of when he first kind of came upon layout. He'd experienced it, he'd seen it, he knew about rework and stuff, and it's like stalking at people, and he calls up one of his good friends. He says he remembers the spot in the parking lot that he was in. He's like, hey, what if I built a machine that did the layout? And he said there's just silence. Guy's like, can you actually do that? And that's when he knew he was onto something. So he started talking to more people. They're like, yeah, it's a huge problem. Rework sucks. Guys misadd measurements in their heads, drawing revisions, and just the amount of time we have to have the floor open to do layout, just even that alone is a problem. As soon as he started talking about it, he got a ton of feedback. Yes, this is a real problem. We need a solution for this. And that's what kicked off his idea to solve this problem.
So what markets are you heavy in right now? I mean, you're in Texas. I'm interested to know this because being, national with doing my robotics with outdoor automation, I've noticed certain states are way more open to automation than others, and a lot of it revolves around unions and stuff like that. So A, the question would be, what states are you in? And B, if you're running into any union kickback on some of these bigger commercial jobs.
So we are heaviest in the New England area, kind of centered around Boston, and we call the Texas Triangle. You've got Houston, San Antonio, Austin, and Dallas all kind of form this little triangle that you can drive to. So we do projects in all those areas. So we're kind of a very heavy right to work state and a very heavy union market. So we've learned to navigate both. What's interesting that we found is everybody asks the union question, and unions are usually the first to adopt technology. Because yes, they may be resistant to it taking somebody's job, which is totally a reasonable concern, but they charge the highest rates for the best quality work. And the way to achieve the best quality work is to use the best quality technology. So while they may kind of fight about who's running it, it's not a fight about whether or not it will be run. And that's where we are right now. We're talking with different unions about who is the right union to operate this equipment, rather than this equipment should not be operated.
That's a great answer to that question, Logan. So like I said, I was a union electrician, and that's one of the things that I've always said to people is, I have 5 years of training. A lot of what I know today in automation is I could really go back to the schooling I had as a union electrician, and so yeah, I mean, that's a great answer to the question. And I can tell you from my days in the union, there's plenty of people that wanted to just turn, put in, pipe it, pull it, trim it. but there was not a lot of people that wanted to run the work. A lot of people don't want that stress of laying it out wrong.
Mm-hmm.
So it probably fits in pretty well. And if a union contractor adopts it, then yeah, they can say, hey, we'll have less back charges and rework charges. So that's awesome that you guys figured that out and were able to identify that early for your market. So looking at stuff that I've built, like I said, I'm building that house right now, and I plan on building more. So if I wanted to build, now this is going to be small, but let's just, it could be either example, but a 2,000 square foot house, and I wanted to use your robot since you're doing it as a service. Do I just send you all the PDF drawings of it? You pre-program the robot and ship it out to me, and I set it in a certain spot, or you send your people out? How does that work?
Yeah. So it is a end-to-end service. You send us data and we do the rest. So the data that we take in for architecturals and some of the trades, we pull straight out of the Revit model. It depends on the quality of the model. So that I'll get to this in a second, but we pull straight out of the model. We'll crunch that. If you've got a schedule of locations that need drilled or hangers or pipe runs, we can pull straight from that CSV schedule what you'd send to a total station for what you need to lay out. We can take that into, we basically combine that all together into here, robot, this is what you need to go do now. Do it in the most optimal way you can. And then we will show up with the robot. We will use building control. So we use the control that they're already setting. So probably, as you know, most construction projects, you have to somehow translate the digital to the real, and you need that reference point of where in the digital model is this in the real world. Those are building control points, control lines. We use those same points and lines for the robot. So we will show up, we'll set up on those control. We actually do a process of making sure that your control is good and what you think it is. Because if control is bad, layout is bad. So we've learned that over time. So we will verify that for you. And then we set the robot running, and it just moves around. It's slow, methodical, and accurate, and just prints what you need it to print.
Now, this is awesome. So developing this, and I think I already know the answer because you alluded to it at the beginning, but, compared to some of the teams you ran, well, first of all, how many people are on the team at Rugged now?
We've got 30 right now.
So much more than the 3 to 5 that you were leading with NASA, right?
Yes.
No. Where do you guys see yourself going? I mean, do you see yourself getting this to be a national model? Like how do you keep growing it, and what are you guys doing? I mean, did you have to raise a bunch of capital? Have you been able to kind of explain that process a little bit?
Yeah.
What in mind? Yep.
Yeah, of course. So we are a venture-backed startup. So we did the Shark Tank equivalent behind closed doors and convincing people that this is a good idea and it's possible to do. So we've raised 2 rounds of funding, which has enabled us to really do this growth, which has been a fun and interesting experience. And really our goal is to deliver this as a service nationally, internationally, and kind of operate in all the different markets. So the long-term goal is that there's always somebody within driving distance of you with a rugged robot that can show up and do your layout. And that, we've got kind of plans to hit that goal. Right now we're in the growth and expansion phase. So the technology works. We're happy, we're proud. It can work better. It needs to work better. It's not perfect, but it is good enough to do layout. So while the technology continues to improve, right now we're really focused on sales and execution. So most of our growth over the next 18 months is going to be exclusively in sales and execution, standing up more robot operators, operations engineers, operations technicians in different markets to deliver this product, to deliver this service for the customers.
Have you guys been approached to do any layout of parking lots?
We have not. The ink for parking lot lines is very different than what we're putting down. And it also is GPS enabled. So there's a ton of technologies that can be really accurate out in that open space. The magic of what we're doing is that indoor GPS denied high precision localization.
Gotcha. Okay. Oh, well, I only asked because if you look at episode 3 and I think 5, I interview a guy named Gary Rabine and Austin Rabine, both father-son owners, and they own a massive 50-state paving company. And that's what they're constantly asking me is, oh my God, if you can get a parking lot striper, like that's what we need. And it's ironic because I have Swazi paint striper that, like you said, it's all RTK outdoor. I'd be able to use it easily, but same thing, it's a different paint. And so it's like, talk about solving a real world problem, but I get you guys have your hands full with what you're doing. So tell me a little, I guess, background on yourself, because I always like to kind of find out what makes people just so inspired to solve world problems, you know? So tell me, I mean, Logan, for the people that are listening on the radio or in the car, you look like a pretty young guy. You look like you're much younger than myself. So, you know, kind of tell me what inspired you to become the automation person you are today.
Yeah, that's a good question. So really, I got the itch for robotics in high school. I did a program called First Robotics. Some people have probably heard of it. You basically, as a high school team, in 6 weeks, you build 120-pound robots to play a game. So they're big robots. It's big, fun, exciting. I was on a team freshman year of high school, and I was like, I'm going to build sweet robots for a job. And that was what kicked me off on the path that I was on. Got my first degree in mechanical engineering from Illinois and got a very unique opportunity to go start working for NASA. Spent my first time there working in operations for mission control for the space station, which was super cool. Don't get me wrong. Awesome. But I learned that was not for me. Like, I've never been a space guy. I'm a robots guy. But I was able to move into the robotics R&D. And it was funny because I never thought I'd be a space guy. And then here I am designing a robot to go into the pole of the moon and drive into craters that haven't seen the sun in a billion years. It's like, what? Like, so it's cool to like work on those challenges and really like get the chops kind of there. So mechanical design, and then just started building more robots, started programming robots, kind of shifted into programming for humanoid robots at NASA, got my master's degree at Rice. And then really what turned me over is like, okay, I've got this skill set of mechanical, software, a little bit of electronics, enough to be dangerous, but not enough to design. And then the opportunity came to solve a problem. So kind of taking a step back, one of the most impactful internships I had in college was for a medical device company. So I helped develop a muscle biopsy needle to take larger samples of tissue from the leg for a procedure that helped with urethral incontinence. So helping elderly people to maintain their bladder control. And that, I had a higher level of satisfaction from that than anything I did at NASA, just because it was such a small, simple thing, but it had such a meaningful impact to somebody. It was very clear how my engineering expertise was helping someone. And this kind of Derek's phone call was an opportunity to do the same thing with this robotics expertise that I've developed over the years. It's like, yeah, I want to go help people solve a problem and have that tangible, I see the results.
That's awesome. So how many, so your family, like, you have brothers and sisters? What'd your mom and dad do? Taking me way back.
Yeah. Oh, in the Wayback Machine.
Yeah.
So take a step in the Wayback Machine. My dad was a doctor. My mom stayed at home with us. A nice, solid, stable family. 2 older siblings. Both went into totally different things. My sister is in journalism. She now ghostwrites for CEOs for companies. My brother went into personal training. Very accomplished personal trainer. Kind of working at some really cool gyms, and then me doing robotics and engineering. So really diverse skill sets. None of us followed the others. I think there's a little bit of, I'm not going to do what they did as we grew up. But, you know, my family background, my family was amazing. I had such an amazing opportunity growing up, and I loved seizing that. I also love trying to pay that back. So like I said, the First Robotics program, tomorrow I'm actually going to volunteer at one of the events. I mentored teams for a long time because like that program is what got me to where I am today. So I always try and feed that back in and use the opportunity and the learning that I've got to help other students develop. I had a great opportunity to teach a course at Rice University, and that was incredibly satisfying to, you know, teach the collegiate level and try and give mentorship. So I'm like teaching in this really academic setting, robotics in an academic setting, going through the course material, like, okay, let's talk about the mathematics of how you do this control. And I'd like finish the proofs and then be like, all right, time out. Here's how we actually do it in the real world so that you can take what you've learned here and actually apply it, and trying to always bring it back to what I've done, to try and kind of be an inspiration for applying academics into the real life settings. So that's something that just try to use the opportunities I've been given to better people coming after me.
Yeah, you're a real people person. I mean, you really, I mean, it's like, so you were at NASA making a robot go into a crater that hadn't seen sunlight to, I hear you saying, a million years?
A billion years, basically.
A billion years.
I can't know the physics, but I don't think that's important right now.
You know, but that was kind of like this is cool, but means nothing. And then you make something to keep someone from, having incontinence issues, and now that boom, you're helping a person, and now you're mentoring people. So I think it's great. So did you grow up? I mean, sounds like Midwest, right? Like,
how'd you know that?
Yeah, we have a typical voice, right? So I mean, definitely you didn't come from Boston, you didn't come from Texas.
No.
So I mean, where'd you grow up?
I grew up in West Lafayette, Indiana, back door to Purdue University. Which afforded a lot of cool opportunities. Like, I was around Purdue's campus and involved in a lot of those programs through high school, which was great. And then I had a chance to not go to Purdue, so I took it and went to Illinois, but still very Midwestern. My wife is from Western Iowa, and she went to Purdue, so a very Midwestern family through and through. And I think that, you can tell from my demeanor. I was my church small group the other day, like, oh, you guys are from the Midwest? That makes so much sense. You're so like calm and like polite, and your kid is so calm and like mild tempered. Yeah, you're a Midwesterner. That makes sense.
So it's crazy because what I find I grew up in Illinois, Northern Illinois area, and we have such a different work ethic. That's and there's gonna be a lot of people that I'm gonna piss off when I say.
I know. I was like, ooh, it's strong.
Yeah, but listen, I mean, this is what it comes down to. And I say this because, like, right now I'm in Fort Lauderdale. Okay. And there's a lot of people that work very hard down here, but there's a lot of people that are distracted by the beach and it's too hot and they don't want to work. And why I say this is because it's really easy for me to sell automation in this state. Okay. It's really hard for me to sell automation in Illinois because at the end of the day, take Lake Michigan out of the equation. It's people that have been farming their whole life and they don't know what it's like to not work. So there is no such thing as an 8-hour workday. People work it like what I find is, if it's sunny, people are working. If it's dark, they're not. Like it's kind of one of the things that I've seen in the Midwest, So it's not a thing against them. And even down to like where I'm building that house in Door County, I don't know if you've been to Door County, Wisconsin, but I'm building an Airbnb.
I know of, yeah.
Okay, so you should go. I will offer this to you. Check out my Airbnb. If you're ever in the area, I'm in a weird rental area where I can only rent. Like if you wanted to rent that house, it's got to be a 7-day rental. If you decide to take it for 3 or 4, I can't rent it to anybody else. But if you're ever in the area and I'm there, hit me up.
All right.
I've got a place that'll sleep 14 people. But the reality is, same thing even up there. They can go fishing, they can run a boat. There's so many things they can do. The tradesmen don't want to work during hunting season. They don't want to work during shipping season. I mean, it's insane. So anyways, I don't mean to piss anybody off, but it's reality. There's a lot of problem solvers that come out of the Midwest because there's a lot of work that happens there. So anyways, I'm going to get off that soapbox so I don't piss anybody off. But so you said you met your wife. Did you play any sports? Were you a sports guy?
I was. I wasn't any good at them for a long time, which is part of the reason I think I've been professionally successful, because all I could do well was school. So I was good at robots and good at school and bad at sports. And weirdly, when I turned 18, I suddenly got good at sports. I started, actually playing in the football games. So I did football. I loved basketball, but was never very good at it. Again, until I turned 18. Ran track, dropped a bunch of time off of my runs. So which is actually, like I said, I think a blessing, because it made me focus on academics until I kind of got pretty stable there. And then when I went to college, like was just generally more athletic. I started running a lot, ran my first marathon as a freshman in college, and have been doing half marathons ever since. I played, ultimate frisbee. I like play golf. When I came to Houston, played a lot of sand volleyball. For years, I was doing sand volleyball 2 or 3 times a week. Started playing like the upper leagues, which was just so much fun. And then a pandemic and a baby later, there's just not quite enough time to go play that quite as much. But still running a lot. My wife and I actually are both runners. That's how we met. It's kind of a fun story. The first and second date, as far as I was concerned, she didn't know they were dates. We did half marathons together. And then the third date was after the second half marathon. It was a trail run. So we camped the night before. She left her sleeping bag in my car, and I wrote her an actual ransom note with cutouts from magazines saying that if she ever wanted her sleeping bag back, she had to let me take her on a date. So that was the first official date. And the rest was history. We've been married almost 5 years now. Awesome 18-month-old kid, which is just the fun age. We really wish we could just skip the first 12 months and kind of go right to the 18-month point that we're at now.
Yeah. So first of all, I love that story of the ransom note. That's pretty awesome. And I like that she didn't know we went on 2 dates beforehand, So that's pretty awesome. And to give you a little background, first of all, I'm gonna ask you a question. How tall are you? Because it's always hard to tell on podcast. Go ahead.
6'3".
Okay, so I'm 6'4". And ironically, I feel like so I'm 44 right now, but I feel like I really came into myself late when it came to sports, because I just think that it sometimes takes taller people a little bit of time to grow into their body,
Oh, yeah.
And I played football myself. I wrestled for a short period of time in high school, but I always think man, if I had played college sports, I would have been such a better athlete even than I was. And I'm a big guy. I was 240 pounds in high school, so I was tall and big. But anyways, my point is I played sand volleyball also, and you met your wife running, and I met my fiance playing volleyball.
Oh,
and
nice.
I played sand volleyball also, and got to the point where I was actually playing fours, which was awesome. And I much prefer to play fours, with co-ed fours. So anyway, so we have that similarity. And I too, now I didn't stop playing volleyball because of the baby. I stopped playing volleyball because I've never injured myself playing sports, and I felt as if I was going on borrowed time. So so during the pandemic, basically, I stopped playing volleyball. I was like, all right, I'm going to grow up here, and I'm going to just focus on my business while I still have my knees and Achilles and all the other stuff.
The thing about sand is it's so much lower impact than a lot of the others. I started developing some good shoulder problems with the spiking, though. I actually moved to center on our co-ed team. So we had a 6'7" indoor hitter on the left side, and then a shorter off-speed hitter on the right side, and then an excellent defensive specialist in the back. So then I was able to just set and block all day. And we got to the point we were pretty good. It was fun.
Yeah. See, for me, I always played outside hitter, and I never developed any shoulder issues. The thing for me was I was always a pretty good hitter, but my defense sucked. So a lot of times people didn't want me on their team, but as I matured, my defense got better and better to the point where people were like, hey, yeah, you should play on our team. So it was really cool, So yeah, volleyball is an amazingly fun sport, especially as an adult. So not to stay on that topic too long. So, what I think you started to go into it, but maybe you didn't. Do you have any mentors that you want to mention in your life that have gotten you where you're at?
Yeah. So I've learned something from every manager and coworker that I've had. One of the things I always try and do is take the good and leave the bad. Understand what people liked about them, what I liked about them, and what people didn't. I have a couple of previous managers who did some things very, very well, and I still use some of their techniques, and some things that rubbed people wrong that I try to avoid. But always trying to take each one as a learning opportunity. I think the most influential one, I had an opportunity to work with an oil and gas company in Australia, and the manager of their team is still my favorite manager to this day. He mentored me. I still call him up whenever I have people problems or growth problems, but his empathy and understanding of his team was better than anybody else I'd worked with. And that's kind of where I got my adage of treat people like people, not like numbers. So understand people, where people are coming from, what drives them. One of his big things that I've always instilled in myself is people don't have strengths and weaknesses, they have traits. So put them in positions where their traits are strengths. And
I love that.
yeah,
I love that. That actually, I'm going to have to like replay that over a couple of times so I get that quote properly. It's because that's actually perfect. Yeah, because all too often we try to put, the round peg into a square hole.
Mm-hmm.
And, I've always said this to my team, because sometimes I've promoted people that were not great workers into management. And then the great workers are like, that's bullshit. They were lazy. They were never a good worker. And now they're in management. But it's like, yes, but they have a different type of mindset. And the great worker will never take the time to manage because the worker just wants to get their stuff done. So they never want to take the time to train other people. But sometimes the person that doesn't want to break their back all day will take the time to step back, A, think about a different solution like you guys have, and B, train the team to do it quicker. So it's kind of interesting you bring that up.
I think a great example, and I'm not the first one to say this, is to give the most complicated task to the laziest person. Because in that case, you're using their laziness as a strength. Because they're going to look in and find the easiest way to do that very complicated thing. And you're going to get some piece of automation, some solution that is the easiest way to do it. And the easiest, most streamlined way. And so like, that's a great example where some people are like, oh, they're so lazy. But like, yeah, if you give them the right task, you can get a better result from the diligent or more detail-oriented person.
Well, and I get that. I mean, I'm in a unique age right now because I'm young enough to still be into technology, but I'm old enough to have worked with people that never thought this would be the case, And, so often I hear people say, oh, the new workforce coming in, they're just all lazy and they're all entitled and they don't want to do anything. But I'm always trying to remind them that, we used to have to handwrite out our research papers and, be typing them with whiteout when we'd mess up. And nowadays, the younger generation, I mean, they've been doing homework on a computer. They've had a cell phone in their hands from the minute they were born, basically, So of course, they're going to have different thoughts on how things should be accomplished in the world. And that's a good thing, because things, if we continue to do it the old way, we're not moving forward. And if we want to still say we're the best country in the world, well, we can't continue to be a great country if we're stuck in the ways of the 60s. So I think that there is really no such thing as a lazy person. There's just intellectual people and there's get it done people. It's kind of the way that it goes, So I streamed past your wife. She said she went to Iowa. So what does she do? I mean, right now you just had the baby, so maybe she's lucky enough to be at home with your baby. But what did she go to school for, and what does she desire to be?
Yeah, so she's from Western Iowa, went to Purdue University for aerospace, graduated top of her class, and also worked at NASA. So that's how we met. We knew each other when we were in college, both interning at NASA. We didn't start dating until we were both full time. And she is in mission control for the International Space Station. So she's a flight controller for, it's called the ADCO console, the one that actually like flies the space station and how does the space station move around in space. That's her. But she spends most of her time now training other flight controllers and training astronauts who are going to the space station. And she's starting with other groups now, like working with the Boeing mission control system for their new capsule and working on their training side. So she took the maternity leave and she's back at work. She is a very bright, exceptionally bright and motivated, and she is very detail oriented and very good at her job and very good at teaching. And I don't think she'll ever want to be a stay-at-home mom, which is fine. It's really whatever she wants to do, I'm going to support her. So, we'll see if we're both career oriented forever, or if one of us wants to step back or what. But trying to support her for what she wants to do.
Hey, listen, I think that's great. I think that this is my opinion on that. Another hot topic in society right now. That's to each their own. If
Yeah.
you can stay home and you want to, that's fine. I mean, listen, I can tell you as a man, if I could have stayed home with my daughter and my wife wanted to work, I'd have been happy. But on the flip side, I like to be out with people. So it's yeah, either way, and that's pretty awesome. It's actually cool talking to you because you know, I still talk to people that don't even believe we've been on the moon, but you're telling me that you made things that go on the moon to go into craters on the moon. So, are there any cool NASA stories that you can actually share that you won't get in trouble for sharing? Because I don't know how that works at NASA.
It's pretty much an open book. Almost everything at NASA, almost everything you can go get. It is mostly public domain knowledge. So people often think like, oh, it's secret. Like, no, it's DoD. NASA's all public. So my wife has a few. So she's obviously, like I said, she's worked with astronauts. She trained astronauts. She got a call on her birthday from the space station. So they like pull up the phone and one of the astronauts there is a big people guy. So everybody who trained him, he had a list of their numbers and birthdays. So on their birthday, like he called her from space and wished her a happy birthday, which was pretty cool. I think like some of the stuff. So I was fortunate to do robotics, very tangible, a lot of like kind of good things to show off. So a lot of the tours that would come through, I'd get to participate in. So I was able to drive, celebrities around and congressmen around in the rovers and like kind of talk to different people about stuff. And it was always those moments that reminded me how cool the job was. That like people come here to see me do my job, which is really neat. And the other thing is everybody who works at NASA wants to work there. Every one of them could go make more money elsewhere. It is not the highest paying place, but everybody's passionate about what they do. So people are doing stuff that I would find menial, but they love it because it's space. And that's super fun. I heard a lot of interesting stories about astronauts. I think really if you're ever in Texas or Florida, they both have Saturn V rockets, what we went to the moon on. And if you ever have the opportunity to go see, they're both free to the public, and you walk into the room, it's the rocket laying on its side, and it is the most awe-inspiring thing I've ever seen. If you don't think we went to the moon, go check out that rocket. It is just absolutely gorgeous, and it is cool. And there's, I think, last story, once people often think that NASA, SpaceX, Boeing are all competing, and that is certainly not true. NASA funds a lot of SpaceX and Boeing, but they're also doing a bunch of stuff NASA isn't, because that's where society needs to go. Low Earth orbit is becoming commercialized, and it's awesome that SpaceX is doing what it does so that NASA can focus on the science of exploration and pushing technology to that next step and really making those huge advancements and those deep science experiments, and let other companies figure out how to commercialize and mainstream the products from there. A good example, I remember the Falcon 9 Heavy that has the central rocket and then the two burners, and all three came down and landed. We like paused our meeting, watched that launch, watched those boosters land on the pad next to each other, and we're just like, this is awesome. Like, it is a team effort, and we see the stuff SpaceX does and like, awesome. Like, that was so freaking cool. I freaking love like working here. So it's another kind of misconception that I think people don't realize.
Yeah, I mean, so I am fascinated with space. I actually tell people this constantly. I mean, if you look at like what I follow on TikTok and Instagram, it's all things about space. It's fascinates me. And
I've got one more good one for you.
Good. Let's go through it. Yep.
This is a secondhand story. My boss was getting dinner with one of the leads for the Mars rovers. The rover that came into Mars atmosphere, and then the sky crane lowered it to the surface and then flew away. Everybody knew they were doing that. We're like, that is the craziest thing I've ever heard. There's no way that's like the easiest way to do this. And so my boss is getting dinner with them. They have a drink, and he asks like, so sky crane, think it's actually going to work? This is before they launched it, or I think it was on the way. He goes, oh yeah, it's going to work. It was It was very well thought out. It was the best choice to deliver that large of a vehicle to the surface. The aerodynamics are not that difficult. Like we're very, very confident it's going to be fine. What I'm worried about are the bearings and the wheels. And it's interesting that people see these grand, complex things like, oh my gosh, that's so complicated. And it's the little details that get you. The Mars dust, we can't simulate Mars dust. We don't know, we don't have any. And it's just a different material property, and how that's going to affect the bearings and the grease. And will that wheel seize sooner than we expect? For the moon rover we worked on, the surface temperature was 40 Kelvin. That's negative, like 400-ish Fahrenheit. And how do you have materials that work on that? Lunar dust is super weird. How do you prevent it from getting into the bearing and tearing it apart? And at the same time, how do I keep my wheel cold or my motor cold because there's no air? Like, how do you vent all of that to space? So it's these little details that are actually the hard part of space, not the overall concepts.
See, this is the kind of stuff that makes me just want to come hang out with you, because we don't have enough. I mean, I have a million questions to ask you now on all that stuff. And so here, I mean, I'm going to tell you, like, I feel like I want to have a podcast with you and your wife if you're interested in doing it.
Yeah.
Just to talk about NASA stuff, because now that I know you could talk about this is awesome. Because so like, first of all, I want to bring up that whole bearing thing you brought up, because so I do automation. You may not know this, but I pick up golf balls robotically. I wash them automatically, and I cut grass automatically. Right. And when I moved out of the Midwest and I came down to Florida, the thing that we're dealing with is there's a lot of sand in the soil, and that sand is getting in the bearings. So a bearing that lasts 2 years on my robots in the Midwest, I'm getting only 6 months in Florida. Yeah. And I'm trying to relay this to the manufacturer to say, listen, you have to figure out a different type of seal, because what they have on their bearing, they just have a nice, it's like just kind of like a rubber seal. They're sealed bearings, but what happens is the sand gets caught in that rubber, and then as the bearing starts to bleed because it's hot, then it builds up there. Once the sand gets inside, it gets destroyed. Yeah. So it's funny you bring that up. So so first of all, I do believe we were on the moon. I think there's things about the moon that just are trippy, like for the fact that we don't see the other side of it, right? And so did you guys make anything to be on the other side, or NASA doesn't care about the other side? Like, so that's a question.
Yeah, I did not. So we were going to the lunar pole, which has interesting dynamics because of the angle of the moon. But one of the things they're working on now is a space station to go around the moon called Gateway, much smaller than the International Space Station we have now. But there's lots and lots of interesting science you can do, because it can go on the other side. And I had the opportunity to go to a conference with a bunch of scientists to understand what types of science can you do with that type of space station to make sure the station was designed to be able to do all of the cool science things. And just listening to some of these people talk, and like the things they're thinking about was wild and trippy. And like, we're talking because of the orbit, you can do a laser experiment to get timing so precise that it would have drifted 4 seconds since the Big Bang, which allows you to do quantum physics experiments that you can't do in low Earth orbit. I still don't really understand it. That's about what I got out of it. But to your point, the dark side of the moon, they want to set up RF antennas, because Earth is incredibly noisy from a radio frequency perspective, and the moon would block it. So if you're on the dark side of the moon, the back side of the moon, you can listen to deep space in ways you can't from Earth. And you can actually use that platform to observe deeper space more effectively for new science. So a bunch of people smarter than me doing some really cool stuff associated with that.
Yeah, well, and so it's fascinating. And then when you brought up, like I was watching something with Elon Musk, and he was talking about how we would get to Mars because you have to line it up perfectly in the orbit. And, it's like, that's the kind of stuff that just fascinates me, because it's like, I feel like if when I was in school, if they were talking about stuff like that, I would have been so engaged, My biggest problem with school was boredom. Everything they were teaching me, I was just like yawning, like this is just dumb. But then I hear people talking about outer space and how you figure out the best trajectory to get to Mars, and it's got to be within this certain orbit, and basically we have a window, what is it, every 2 years to do it, and it's fascinating because you realize it's just a wide open space in vacuum. You cannot do anything without propulsion because there's no air to move. So without propulsion, without a rocket, you can't move. And anyways, it's fascinating. So I'm telling you, I could. So.
My wife's collegiate expertise, so like specialization, was orbital dynamics.
So yeah, see, this would be a great podcast.
Yeah.
I would just be in awe listening. You guys would solve like half of the things that I think about. Well, you wouldn't solve it. You'd actually make me. But yeah. So,
yeah.
Anyways,
kind of skipping back on the bearing story. And getting back to Rugged and what we're doing. You can't have a name like Rugged Robotics without having a robust robot. And construction is demanding. So I've taken some of those lessons of devil's in the details and how do you make something robust, and we're applying it here. So our current platform, we've cold soaked it to -6 in walk-in freezers. So we test in the coldest that people would be willing to work. We test it in a literal sauna, 110 degrees with 100% humidity to make sure it works in that. The robot's designed to be kicked. So a steel toe to the side or anywhere on the robot's designed to be dropped, slips out of your hands or, drops off, like whatever. It's got to be able to fall and survive. Hammer dropped on it, a wrench dropped on it, has to be able to just keep working. So kind of applying that, that robustness concept to our robots to make sure that they survive the construction environment, because it's demanding and it's got to work in any condition a person can work in. The robot's got to be able to just work in. I'd be real pissed if my machine couldn't handle the same cold that I could handle.
Yeah. No, that's a great point, because then you've got to have like battery warmers and stuff in that thing, right, in order to make it work that cold.
Yeah. So batteries are interesting. That one, we've spec'd it to be able to charge batteries up in time to discharge, like just kind of the charge discharge rate. We've done a lot of projects in Boston. We know how long it takes for cold batteries to charge, and we have heaters on the ink. So the ink won't freeze, even though it's an ethanol-based ink. Alcohol freezes if you get it cold enough. So there's the cold and then the hot and the humid. We've done projects in South Florida, and Texas is very similar. 100% humidity is a thing. So it's got to be able to handle that condensation and not have any problems. Because construction's hard.
So do you guys clear coat? Because usually like layout guys, they paint it, they mark it and then clear coat it. Does your ink not need the clear coating? Once you ink it, does it stay?
We don't normally. You can. It helps it be a little bit more visible. But if you take a broom, you can see it again. And actually, interestingly, you can clear coat it later and it'll just kind of pull it up to the surface. But it impregnates the concrete far enough that it really stays and is pretty resilient. And we have no cases of bleed through yet. That's another common question. You're like, oh, what if I put flooring on it? Because like some Sharpie and paint markers will bleed up through laminate tile. And ours, we have no data that says that it does that. We have some experiments running in the lab to make sure that it doesn't for customers. We literally just dump it on the back of laminate and tile, not even putting it on the concrete and putting it on the tile. We just poured it onto the tile to see if it bleeds through ever. And we're like 3 or 4 months into that and haven't seen any yet.
Yeah, I think you're safe, but that's just my opinion.
Yeah.
I mean, I always end my podcast with the question of what do you want your legacy to be? Except you're a young guy, I feel like you're going to have a million things that you're going to work on. And I feel like I already know, because you want to help people, but in the space, what you're doing right now, what is that where you want to be? Do you want to keep going with that? If you could retire in 10 years, what do you want your legacy to be?
Oh gosh, that's a very complicated and loaded question. I've got a lot of life ahead of me. In the space that I am now, what we're doing here at Rugged, I want to start enabling automation on on construction. Construction is incredibly difficult to automate because it changes every day, every hour, and it's never quite what the model says. In manufacturing, that part's going to come down the line at the same spot every time. And in construction, that pallet of sheetrock is going to move 4 times today. And how do you start enabling automation in that really complicated environment? And we think this is the best spot to start applying automation because it's the most controlled, the most open environment. And then I want this to be the launching point to start automating more things. If you think in 100 years that we're going to have as many humans building buildings as we do now, I think you're not thinking about it in the right ways. We're always going to need buildings. We're always going to need places to learn, eat, play, and we're not going to want to build those by hand forever with the way technology's going. So I want this to be that launch point for doing work on a construction site. And as far as my personal legacy, I want to leave the world a better place than I found it. I'm having opportunities of that professionally with Rugged to continue to augment the labor force. At the very least, I'm saving knees and backs because you don't have to bend over to run this machine like you do with the chalk line. And, when I can, mentoring, growing my people who work for me, growing people who, opportunities I have to mentor high schoolers or college level. And then long-term, I'd love to be a lecturing professor at university. Like my goal retirement job is to go teach college and take those courses where I can take my industry experience and apply it in the academic setting. Like, hey, I know you're doing a bunch of math, but let's talk about how the workplace works and how robots work and how real life works, to try and bring that into the classroom a bit.
Logan, you acted like that was going to be a hard question for you to answer. And you basically just went right through the table of where you're at here, what you want your life legacy to be. And so it was fantastic. Great answer.
Thank you.
I loved it. I loved the podcast. I'm being very genuine when I say, like, I would love to do it again with you, with your wife if she wants to be on. Or, even if a lot of times I tell people, like, I love with automation to kind of check in with people like after a year, or, kind of see what's changed, what markets, things you've done. So, make sure you reach out if, to kind of keep us updated on what you guys are doing over there.
Yeah, I think kind of knowing what's on the horizon, I think there'll be some cool opportunities later this year that maybe might make sense to reconnect. And if you do want to do it with my wife and I think we have to get NASA's actual permission since she actually works there, which gets really tricky.
Then we don't need to do that. We don't have to do any podcast that we publish, but hopefully after this, I think you're a pretty cool guy. Hopefully you think the same about me. So, maybe one day or something, and we can just talk about this kind of stuff over dinner.
Yeah.
So
that'd be great.
So
if you ever swing through Houston for anything, you got my number.
So, ironically, I have robots in Houston. I'm working with a landscaping contractor down there. We have, trying to think of all the different places that we have them, because I always say Houston, but there's all like the suburbs of Houston. But yeah, I mean, we've got 60 robots down there right now. So, that's a market I do go in. Yeah. So this has been great. I really appreciate it. I think you guys are onto something. Like I said, as someone that was in the construction industry, sort of still is, I see a huge value with what you guys are doing. I think you're really helping the industry. I think it's great that your co-owner or co-founder actually thought about this and made the solution. And I wish you guys great luck.
Yeah, I appreciate it. Thank you for the time. It was fun to talk to you.